Hey, I thought today that I would talk about atoms, isotopes, and ions. And when you're looking at atoms, isotopes, and ions, they're made of protons, neutrons, and electrons, are the basic building blocks of them. And the number of protons can be read on the periodic table by the atomic number. The number of neutrons is the rounded atomic mass. The number of electrons is the number of protons minus the charge of an ion. So for example, if we looked at lithium, lithium has a number of 3. It's up in the upper left corner there. Its mass is 6.941, which when we are figuring out neutrons will round to 7. So again, protons equals the number, which in this case would be 3. Neutrons is the atomic mass minus the number. And you round the atomic mass to the nearest whole number, which would be 7 minus 3 to get 4. Electrons, if the atom is uncharged, will be the same as the protons. So in this case, it's the atomic number, or 3. Now let's look at sodium. Now sodium is a metal. It's an alkali metal way on the left side of the periodic table. It's highly reactive in water. It will actually blow up in water. And if you were asked how many protons, neutrons, and electrons in sodium, which is number 11 with a mass of 22.99, or if we round that up, it would be 23, we get protons equals 11. Neutrons is 23 minus 11, or 12. Electrons, since this is uncharged, it will be the same as the number of protons, or 11. Now, a slight variant of that is the ion sodium, which is Na+. In this case, sodium loses an electron and gets a +1 charge, since electrons have a negative charge, protons have a positive charge. Now, Na+ is essential for the transmission of nerve impulses. So for example, if there was a tiger chasing you, you would be using the sodium ion to trigger your nerves to run away from the tiger. So if we were asked what's the protons, neutrons, and electrons for Na+, or the sodium ion, the protons, again, would be the same thing, 11, as for sodium. Protons determines the element. Neutrons, again, we haven't changed the number of neutrons here. So again, that's going to be 23 minus 11, or 12. But now the electrons is going to equal the number of protons minus the charge, or in this case, 11 minus 1, which would be 10. And this is just showing a little picture of a axon, and showing that sodium will enter into the axon. It creates an area of plus charge that will run down the nerve with the nerve impulse. And that's an example of an ion. And basically an ion is an atom that has either gained or lost electrons. If it loses electrons, since electrons have a negative charge, the ion gets a plus charge. If it gains electrons, then the ion has a negative charge. And often ions are made of atoms. They can also be made of several atoms together. So it can be a particle or a compound that has gained or lost electrons. So like sulfate is SO4 and then 2-. Again, electrons have a negative charge, so if the atom loses an electron, it gets a net plus charge. If the atom gains an electron, it has a net minus charge. Now, you might ask, why aren't ions caused by a gain or loss of protons? Because protons have a plus charge. If you change the number of protons, it would also change the charge of that particle. But protons defines the element. So if you change the number of protons, you actually create a different element. And in terms of why do some atoms gain or lose electrons, whether they gain or lose depends on creating stability within that atom. Generally, metals will lose electrons, and nonmetals will gain electrons to be more stable. Now, in order to count electrons, again, to kind of summarize things, if you have an H plus ion, hydrogen is number one. It has a mass of 1.007 atomic mass units. So the protons equals 1, which is the atomic number. The neutrons is the rounded mass minus the number, or 1 minus 1, so 0. Electrons is the number of protons minus charge, in this case 1 minus 1, or 0. So an H plus ion is simply a proton with no neutrons and no electrons. If we were to then look at fluorine, fluorine is number 9. It has a mass of 19. So if we were to look for that, the number of protons is the same as the number 9. The number of neutrons is the mass rounded, so 19 minus 9, or 10. And finally, since we're looking at fluorine minus, it's a negative ion with a minus 1 charge. So then the electrons is the number 9 minus negative 1, or 10. Now, ions are created by gain or loss of electrons. It's also possible to have a particle with the same number of protons as another particle, but different numbers of electrons. And those are known as isotopes. And isotopes come in really handy in terms of things like radiometric dating. So when they do carbon-14 dating, or when you're looking at past history of climate on Earth, they actually use different isotopes of oxygen. If you're working with dealing with thyroid cancer, you actually use a radioactive tracer known as iodine 126. So it's iodine with a mass of 126. The carbon-14, most carbon has a mass of 12, carbon-14 has a mass of 14. Again, if you wanted to learn about climate in Greenland, say, over the past 400,000 years, you can use the abundance of oxygen 18. Now, as it gets hotter, you tend to get more and more oxygen 18 in the precipitation because it's heavier, but with it being warmer, there's a little more there's more kinetic energy, and that allows more of the oxygen 18 to get into the atmosphere and then fall as rain or snow in this case. If it's colder, less of that oxygen 18 gets into the atmosphere. It tends to fall out earlier. It doesn't get to Greenland or to Antarctica, and you don't tend to get it building up in the snow as much. And again, all of those are isotopes. So isotopes are different kinds of the same element. Chemically, they act exactly like that element, but they do have a slightly bigger or smaller mass, so that can affect their how many of them there are in a sample of that element. And again, they have the same number of protons. Chemically, they act the same, but a different number of neutrons, so they do have a different mass. Once again, why can't protons cause the mass difference? And same answer. If you change the number of protons, you make a different element. To do the same thing we've kind of been doing, if we wanted to count how many protons and neutrons and electrons in copper-65, which is an isotope of copper, copper is number 29. The number of protons is the atomic number, which is 29. The number of neutrons is the mass. In this case, rather than using the periodic table for the mass, we use the isotope's mass, which is 65, minus the 29, 36. The electrons, since this is uncharged, would be the same as the protons, or 29. Now if we try chlorine below, chlorine has an atomic number of 17. If we had chlorine 36, but one that was an ion of -1, we'd have to be a little careful in terms of protons, neutrons, electrons. Since it's number 17, the number of protons equals the number, or 17. Now, neutrons, again, is the number subtracted from the total mass. In this case, the total mass is 36. The number is 17, so 36 minus 17 is 19, so 19 neutrons. And finally, electrons is the number 17 minus the charge, so 17 minus -1 is 18. And just in terms of mass, protons and neutrons both have a mass of 1 atomic mass unit. Electrons, though, have a minimal mass. It's about 1,000th as much as the other particles. And that's just a brief overview of the different components that make up atoms, ions, and isotopes. I thought that worked because there was a ton of kid noise. What happens at the end? Like I just hit buttons until it went away.
That's pretty much what I do. And now it should be uploading.
I don't know.
Click on the screencastify thing because there should be a way to get it to YouTube.
There was a ton of noise.
That your story